During my studies, I realized that in the production of 3D assets, much time is wasted on things which don't have anything to do with creative work, but are only existing because of technical requirements. Everything that I want to do while working on models is modeling, texturing, and placement of the assets. For these things I want to dedicate time. Everything else should be reduced to a minimum, or if possible, be omitted completely. For these reasons, during my work on Goliath 2, I searched for possibilities to optimize workflows during production and implementation of 3D assets. Because I used Unity for the development of this game, I optimized my workflows, especially with regard to this software. The software is used for the creation of the 3D objects, or Maya for low poly modeling and UV unwrapping, ZBrush for high poly modeling, painting and map baking, and 3D code for retopology and UV unwrapping. Particular to the work with these softwares are the integrated app links, which are used to move data between those programs and offer significant improvements regarding an optimized workflow. I'll review those app links later in the video. In addition to those programs, I use the Mixamo service for rigging and animations. Mixamo rigs bipedal humanoid characters automatically and offers a diverse selection for animations for use in Unity. I'll use this scene from Goliath 2 to show you how I optimize my workflow. For the creation of the environment, I worked with individual objects which I instantiated in Unity. While this method is a bit more laborious than if I just built the whole level design in Maya, there are 3 important reasons for me to do the work in this way. First, the influence on the effects of light and shaders are visible directly in the editor. Second, the objects can be quickly edited to test the gameplay. I don't have to change into an external program to change the position or the rotation of an object. And third and last, I think it is highly possible that if you work with several hundred or even thousands of objects, Unity will have problems with the import and will get slow or could suddenly crash. To be able to integrate all the individual objects into the Unity editor as fast as possible and to have all necessary reference files in Maya, I created a reference object in Maya from which I create all other objects. It contains the character, some blocks with the measurements for jumps, and a tree which is probably one of the most prominent objects in Goliath 2. This file also contains all preferences which I need while working on an object for this project, like render settings, etc. So I used this reference object for the level design and started right from the beginning with the creation of the different objects like stones and trees, which are developed from this basic object. This way it was possible for me to adjust the level design during the development of the game mechanic and continue developing. At this point I want to show you the app links which can be used here. Using app links, it's possible to transfer objects quickly into another application without having to manually export or import it. The app link for the connection of Maya and ZBrush is called GoC. To get this object into ZBrush, the only action required is clicking this button, and the model is already in ZBrush and ready to be modified. By using the same function, the model, including diffuse and normal textures, is transferred back to Maya. If this object is to be modified within 3D code, there are multiple options for linking the apps, like one link for UV unwrapping or another for retopology. The same as before, the object appears in the other program right away, can be edited, and then be sent back to Maya on the same way. Additionally to these connections of 3D code and ZBrush in Maya, it's possible within ZBrush to quickly send an image section over to Photoshop to modify it and get it back with another app link. Another extremely useful tool within ZBrush is a tool called Multimap Exporter. Instead of exporting normal diffuse and other maps individually, the Multimap Exporter is creating all textures in one step, which lightens the exporting tremendously. Between Unity and the other programs, there is no tool resembling an applink. Given that Unity automatically recognizes Maya files, saving it in Maya is all that's needed to update the object in Unity. It's also possible to open the selected object from within the Unity editor with a single click. To extend the import and simplify the implementation of objects into Unity, it's possible to extend the Unity editor with scripts using the asset postprocessor clause. This way, imported objects can be directly integrated into prefabs, or components can be added or removed from the imported assets automatically. Here, for example, with this object, there are multiple objects within Maya which have an underline hid or an underline call added after their names. Those are recognized automatically during import, and the objects get adjusted for their purpose. That way, every underlying call object gets its mesh renderer deleted and the collider added. Underline hid objects are only used as references. Those won't be rendered in Unity and won't get any collider. The names of the materials are changed by the scripts in such a way that even if they are having different material names, Unity will recognize similar materials by name and create only one material. Besides, all materials are gathered and allocated in the same folder. All those adjustments are not only usable for objects and materials, but also for textures. Basically, using this system, it would be possible to assign all textures to the desired input of a shader only by using the asset postprocessor analyzing their names. Unfortunately, this wasn't possible with the Unity version used to develop GOLIATH 2 because a bug prevented the assigning of textures. During the work on GOLIATH 2, I used 5 different workflows. These are divided into one workflow for characters, one for terrains, and then 3 for different types of objects. With the help of the character workflow, I want to show you how such a workflow may look like. At the beginning of this workflow, I create the foundation of the body. The C-spheres are simplifying this procedure significantly, because it's possible to modify them very quickly, which enables me to try out different concepts right at the beginning. This model is then converted into a polygon object and further detailed. Because this object doesn't possess any optimal topology, a quick automatic retopology is appropriate. While this model has its polygons distributed equally, it would be better if body parts with many details would have much more polygons than others. As soon as the topology is optimized, the body gets further detailed. Here I tried out a first concept for Mari by applying textures and clothing directly onto the model. Because I wanted to work on the game mechanics of GOLIATH 2 parallel to the creation of the character, the model had to be transferred into Unity as soon as possible, so that I could configure Mechanim and test the character inside the prototype. Ahead of the export, the model is reduced one more time, because at this moment the poly count is at over 6 million polygons. After another automatic retopology, we arrive at 23,000 polygons. Another reduction would be possible at this point, but isn't necessary, because at this point during development, performance optimizations aren't yet of any relevance. The UV map is also generated automatically at this point. This map will also be optimized at a later point. This model is now exported and uploaded onto the Mixamo homepage for an automatic rigging. Compared to manual rigging, this method is extremely time-saving, which allows me to rig this character multiple times during creation to try out multiple designs. After an export from Mixamo, I import the model for the first time into Unity and am now able to configure Mechanim and to test the model. This version works basically But before I continue detailing it, I first have to manually retopologize and UV map it in 3D code. The manual retopology is necessary mostly because of the details in the face and for optimizations regarding the rigging. I think currently no automatic retopology is able to deliver the same quality. The created UV map is mostly special because of the seams right through the face. Basically, seams chosen this way would pose problems if the texture would be modified in Photoshop later. Because I texture this model solely in ZBrush, this method is unproblematic and relaxes the texture in the face. Before I move the model back to ZBrush, I conduct some small changes on the low poly model, mainly in the mouth and eye areas, because there are some small things that have to be optimized. After that, I carry out the final changes and am testing multiple textures directly in ZBrush and Unity and finish the concept phase. This is the model from which I will create the final version. Mainly the face and the hands have undergone bigger changes compared to the last model, which was imported into Unity. After this step, I repeat the rigging in Mixamo and implement the new retopologized model in Unity. After some last changes on the face and the detailing of the suit, I create optimized eyes in Maya and integrate some hair. These parts are connected to the body and uploaded to Mixamo for one last rigging. Parallel to this, I export multiple maps from ZBrush. Here, mainly the creation of the specular map is special because it is painted on a model directly in ZBrush. This is only possible with the use of the right shader, which displays the reflectivity of the painted areas directly in the software. This method lets me skip the creation of a specular map in Photoshop and is, in my opinion, much more intuitive. All these steps together result in the final model of the character, like we see it here. It's obvious that the process of finding an optimized workflow never ends, because the possibilities of creating 3D models are changing all the time. For example, software like Substance Painter from Algorithmic and the new Quixel suite will come to the market soon, and these programs will probably require changes to any 3D pipeline. In the near future, I will launch a section on my homepage in which I will feature tutorials regarding the creation of 3D assets. So I recommend that you check out ourlittlesecret.ch and follow me on Twitter. Thanks for your time.